2x plus 5 greater than equal to 0. If we want to know the values of x, next step will be 2x greater than equal to minus 5, x greater than equal to minus 5 by 2. Now, using this definition from 1 we have got this, then x greater than 1. Therefore, if in interval form it will be now the third case, when x greater than 2. Both will be positive in that case. From 1 x minus 1 plus x minus 2 greater than equal to 4. Morning, welcome to btosacademy. Welcome to my maths class. Today I shall continue the topic inequality. In the last episode, I worked out few sums of inequality. Today, in the first part, I shall work out few more inequations. Then I shall move on. I take this sum first. Modulus of 2x plus 5 greater than 7. Modulus symbol is there. Therefore, in the first part, we have to remove that modulus symbol. Already I have discussed. Let us recapitulate. Modulus x if is equal to minus x if x less than 0, 0 if x equal to 0, x if x positive. Keeping that idea in mind, we first remove. I take equal to sign also, and I call this as 1. Therefore, 1 implies 2x plus 5 greater than 7, or 2x greater than 7 minus 5, or 2x greater than 2. Therefore, x in this case, remember, 2x plus 5 greater than equal to 0. If we want to know the values of x, next step will be 2x greater than equal to minus 5, x greater than equal to minus 5 by 2. Now, using this definition from 1 we have got this, then x greater than 1. Therefore, if in interval form it will be now other case from this equation we get minus 2x minus 5 greater than 7, or minus 2x greater than 7 plus 5, from that 2x less than minus 12. Here minus 2x greater than 12. Now we want to make plus 2x. For that we have to multiply by minus 1, and when we are multiplying by negative number, then the inequation symbol will be reversed. That is why 2x less than minus 12. Therefore, by 2, that is minus 6. Therefore, in this case, x belongs to minus infinity minus 6. Thus, we are getting two intervals. Therefore, required solution x belongs to minus infinity minus 6 union 1 infinity. Note this. In case of modulus symbol, let me repeat. In case of modulus symbol, first you remove modulus symbol, apply this definition, then from the original equation to write the transformed in equation, then solve that. And next part is this. Then after getting these intervals, you combine these two and write required solution, this one. Since in equation, one thing I am to mention, since in equation generally you won't get particular values of the variable, the values of x will be intervals. You may give your answers in this interval form also in equality form. Next, number 2 sum. Next sum, modulus of x minus 1 plus modulus of x minus 2 greater than equal to 4. First of all, we note that the first modulus of x minus 1 and this one modulus of x minus 2. Now x minus 1 vanishes for x equal to 1, x minus 2 vanishes for x equal to 2. Therefore, if we consider the number line, we see, we take this one as origin, x equal to 1, x equal to 2. Then these two values, x equal to 1 and 2, have divided the number axis or number line into three parts. What are those? Left part of x equal to 1, then 1 less than x less than 2, then x greater than 2. To solve such type of inequations, we have to consider the intervals like this. When x less than 1, x minus 1 is less than 0. Naturally, x minus 2 will be less than minus 1. That means I am subtracting 1 from both sides. Therefore, both are negative. Therefore, mod of x minus 1 is equal to minus of x minus 1 minus, and mod of x minus 2 is also minus of x minus 2. We call this as 1. Therefore, from 1 minus of x minus 1 minus x minus 2 greater than equal to 4, or minus x minus 2x plus 1 plus 2, or minus 2x 3 greater than equal to 1. Therefore, 2x less than equal to minus 1. Remember, while you are multiplying both sides of an inequality by negative number, then the inequality sign will be reversed. Therefore, x less than equal to minus 1. When x minus 1 positive, let me say like this, when 1 less than x less than 2, I must mention like this, then x minus 1 is positive, x minus 2 is negative. Therefore, from 1 modulus of x minus 1 will be x minus 1, and modulus of x minus 2 will be minus within brackets x minus 2 greater than equal to 4. Now x cancels, minus 1 plus 2 impossible. Left side 1, right side 4. 1 is never greater than 4, therefore this is impossible. Now the third case, when x greater than 2. Both will be positive in that case. From 1 x minus 1 plus x minus 2 greater than equal to 4, or 2x greater than equal to minus 1 7. Therefore, x greater than equal to 7 by 2. Here x greater than 2, here we are getting x greater than equal to 7 by 2, that means 3.4, that means satisfied. Therefore, in interval form it will be and this is in interval form. Now we have to combine these two intervals. Therefore, required solution x can take the value minus f, also 7 by 2. Therefore, we have to write the intervals in this manner. Now, sometimes it is required to show the solution set on the number line. Here we find x less than equal to minus half, as I have taken this one as origin. X equal to 1, x equal to 2, this is x equal to minus 1. Therefore, this will represent x equal to minus half. Then this is 3, x equal to 7 by 2. Since x can take the value 7 by 2, we have to draw like this. Now, this is the representation on the number line of this solution set. Now, one thing, for x equal to 1, the left hand side will be 0 plus 1. That means left side is 1. That means x equal to 1 is not satisfying. And for x equal to 2, 1 plus 0, that is also not satisfying. Keep this in mind. First you see for which values of x these two are vanishing. Then you divide the whole number line into, in this case, 3 parts and discuss in different parts. And finally, we get This is the solution. Next sum, 3 within brackets x minus 5 less than 5x minus 7 less than equal to 3 within brackets x plus 1. We see this inequation has 3 parts, first, second and third part, and we proceed in this manner. Now from this, 3x minus 15 less than 5x minus 7. Next we take x part on the right side, left side, 3x minus 5x less than 15 minus 7 or minus 2x less than 8. Therefore, 2x greater than minus 8. Therefore, x greater than minus 4. From this part, we get this one. Now, from this, or 5x minus 7 less than equal to 3x plus 3, or 5x minus 3x less than equal to 7 plus 3, or 2x less than equal to 10. Therefore, x less than equal to 5. Now, we have to combine these two. Therefore, also you can write it in this form: x belongs to minus 4 infinity, and this can be represented also: x belongs to therefore x belongs to now if we require to represent on the number axis, If we represent this, then it will be and if we represent this, note x greater than minus 4, therefore x cannot take the value minus 4 but greater than minus 4, that is represented by this one, and in this case x is less than equal to 5, therefore x can take value x equal to 5, therefore less than that, therefore this is the representation of these two separately. Now the common region, common interval will be the required solution, therefore to represent the final one, this will be the representation on the number line. As the sum is solved, now this sum minus 8 less than equal to 4 within brackets x plus 1 less than equal to 7, and it is mentioned that x is real number. We solve it taking two separate inequations. From it, minus 8 less than equal to 4x plus 4, or I take this side on the left, 4x greater than equal to minus 8 minus 4, or x is greater than equal to, this is minus 12 by 4, that is minus 3, and from it 4x plus 4 less than equal to 7, or 4x less than equal to 7 minus 4, therefore 4x less than equal to 3, therefore x less than equal to 3 by 4. Now from this question, sometimes you may find the least and greatest value of x. For that part, answer will be like this, therefore least or lowest or minimum value of x is equal to this one, minus 3. and greatest highest or maximum value. You see, x is greater than equal to minus 3. That means least value is minus 3. And here x is less than equal to 3 by 4. Therefore, greatest value is 3 by 4. Now, required solution set. We have to combine these two. Or the answer may be given like this. Open closed interval, and if we were to express that on the number line, we take this one as origin, then x less than equal to, if I take this one as x equal to 1, then this is x equal to 3 by 4 minus 3 I suggest students you use your scale for scaling. In that case, will be equispaced. Otherwise, intervals will be of unequal lengths. That is not good. That is why my suggestion is that you use your scale. As x can take the values minus 3 and 3 by 4 and values within minus 3 and 3 by 4, it is represented by this. And also we write here minus 3 less than equal to x less than equal to 3 by 4. Hence the sum is solved. Next, I am going to discuss special type of linear inequations. Actually, up to this, I have not taken fractions form. Now we have to take fractions forms. The forms will be ax plus b by cx plus d, here c not equal to 0, that may be greater than k or greater than equal to k or less than k or less than equal to k. K is constant. I am not writing explicitly this one greater than k or this one greater than equal to k, left hand side less than k or less than equal to k. If we get such type of forms, then how we solve this? Let me first discuss what we do. First we take that right hand number on the left. Ax plus b by cx plus d minus k. If I consider this one 0, in this case it will be greater than equal to 0. In this case it will be less than k, less than 0, sorry. Then we simplify. Or take x terms together, a minus kc whole into x plus b minus kd whole divided by cx plus d greater than 0. Now both are linear. Now the value of the fraction is positive. Then two cases arise. Therefore, both numerator and denominator positive or both numerator and denominator negative. Therefore, either a minus kc into x plus b minus kd positive, cx plus d positive. This is one case. Or a minus kc whole into x plus b minus kd, this is negative, also denominator negative. Now we are to consider these two cases separately, and from those two we will get solution set. Now it will be clear if we consider problems. And another thing, if we get negative less than 0, then the two cases will be numerator, denominator will be of opposite signs. That means in the first case, if we consider numerator positive, denominator negative, in the second case it will be numerator negative and denominator positive. These are the ways. Also another thing, if we get the fraction where denominator involves x, if we multiply the expression at the denominator in both numerator and denominator, then denominator will be square form. That means that is positive. We can also progress in that way. Now I am taking few sums. First one is x by x minus 5 greater than half. X by x minus 5. First, let me say, you may think that in the first step, if we multiply on by using cross multiplication, that is not applicable in this case. If you find numerator, denominator are expressions involving x, don't think that. What we do, you see, right side number is taken on the left then we simplify. Follow. Here you first mention this denominator cannot be 0. That means in that case division by 0. Denominator of fraction cannot be 0. First mention. Here x minus 5 not equal to 0. That means x is not equal to 5. From 1, x by x minus 5 minus half greater than 0. I have taken this constant half on the left side. Then we simplify 2 within brackets x minus 5 2x minus or 2x minus x plus 5 by 2 x minus 5 greater than 0. Now to remove 2 is positive number, we multiply both sides by 2. That means we can write directly x plus 5 by x minus 5 positive. Now we get a fraction which is positive. Therefore, already I have discussed earlier, both numerator and denominator will be positive. That is the first case. And second case, both numerator and denominator will be negative. We have to approach like this. Now from this, what we get? From this, x greater than minus 5, and from this, x greater than 5. Greater than minus 5 and greater than 5. That means finally common region is x greater than 5. This is x greater than minus 5. If we represent that on the number line, x equal to 5, say this is x equal to minus 5. X greater than 5 means this one, and x greater than minus 5 means this one. Then you note what is the common one? X greater than 5. Therefore, we conclude this. And from this, x less than minus 5, x less than 5. X is less than minus 5, here x is less than 5. Therefore, common one is this. Therefore, now we get in interval form this one, and in that case this one. Therefore, solution will be union of these two intervals, x belongs to minus infinity to minus 5, union 5 to infinity, these two intervals, union of these two intervals, we can express with the help of number line. This is x greater than 5, this is x less than minus 5. Now union of these two intervals is the required solution.